Very good morning, students. Today we are going to discuss about rule-based classifier or rule-based classifications come under Unit 3 of machine learning. So basically, what is rule-based classifier? So it's one type of classifier which makes the class decision depending on using various if-else rules. Okay, so we in programming we are using if-else condition, no, like that. These if-else rules are used, and these rules are easily interpretable, and thus these classifiers are generally used to generate descriptive models. Okay, so the condition used with if is called the antecedent, and the predicted class of each rule is called as consequent. So we'll see elaborately one by one. So that is the basics about rule-based classifier. Yeah, as I said earlier, it classifies records by using a collection of if-then rules. Okay, so here rules means like condition implies y, where condition is the conjunctions of attributes, y is the class label. Okay, then in LHS side we can call it as a rule antecedent or condition, whereas RHS side, right hand side, we can say it as rule consequence. Okay, so by applying, what is the consequence? That is in the RHS side. So let's see on two different examples. Suppose we want to classify as a bad, then we can have a conjunction condition. We can have blood type equal to warm and lay eggs, yes. Then if both the conditions are satisfied, then we can assume that it's a bad. Similarly, the taxable income is less than 50k and refund also yes, then there is any tax evasion. So these type of conclusion we can come. So these are the two examples. So here see the table. Here we have several attributes, several tuples. See here name, blood type, give birth, can fly, live in water. Then they are classifying it. Okay, so several classification like mammals, reptiles, fishes, birds. Those are all classified. So you from this we can by absorbing it, we can able to write rules. Okay, so what are the possible rules we can write here is rule 1, give birth no, can fly yes, then we can say bats because bats lay egg, right? So automatically that is we can create one rule R1. Similarly, another one rule, give birth no, live in water yes, definitely fishes. Then give birth and blood type is warm, then we can say it is mammals. Give birth, no. Can fly, no. Then we can say it's reptiles. And live in water sometimes means then amphibians. Okay, because they are both living, I mean, they live in both water and land. So these are the rules we are creating. Then when a new instant is coming, by applying this rule, we can able to classify it. Okay, so this is what happened in this rule-based classifier. So application of rule-based classifier. See here, a rule or cover an instant X if the attributes of the instance satisfies the condition of the rule. So if any of the conditions in the rules are satisfied, then we can identify the thing. For example, we have two examples here we mentioned. We know 5 rules already will be derived. Hawk, blood type is warm, give birth no, can fly yes, live in water no. So we have to classify it. Then another one, grizzly bear, warm, blood type, give birth yes, can fly no, live in water no. So now by applying the rule R1, because give birth no, can fly yes, automatically hawk is a bat. So we can classify it. We can easily identify that hawk is a bat. Then, by applying rule 3, we know give birth yes and blood type is warm and it is one of the mammal. Grizzly bear is a mammal. So this is the way we can apply this rule and we can able to identify the classification. Then rule coverage and accuracy. So how far the coverage of rule happen? Fraction of records that satisfies the antecedent of the rule, accuracy of the rule in the sense fraction of records that satisfy both the antecedents and consequence of the rule over those that satisfies the antecedent. Okay, so here let us take the tax evasion example. In that we have attributes like refund, marital status, taxable income, and we are classifying it, isn't it? So depending on the content, we can say the coverage value as well as accuracy value. So status singly automatically stack evasion is, sorry, tax evasion is no. So here coverage 40%, accuracy 50%. Okay. See the table, you can understand. Then decision tree versus rules. From trees to rule. Actually, we can convert the tree into set of rules, right? So one rule for each leaf, like that we can convert. Antecedent contain a condition for every node on the path from the root to the leaf. Similarly, consequent is the class assigned by the leaf. Straightforward, but rule set might be very complex because for a different trees can be drawn for a scenario, right? So automatically it become a complex one. So here outlook sunny, overcast or rainy. So sunny because checking humidity, if it is normal, there is sunny, no means humidity, no. Then windy. So these are the things. This example we already discussed in unit 1. The same example they took here. So from rules to trees, more difficult one because transforming a rule set into a tree cannot easily express distinction between rules. Example, if A and B then X, if C and D then X, corresponding trees contain identical subtrees, replicated subtree problem also there. And similarly, we can have more than one different variety of trees. So it is very difficult to convert it into tree to rules. Okay. So here, how does rule-based classifier works? Again, we use the same 5 rules we define by seeing the attributes table. And here, lemur, turtle, and dogfish, shark. These are the things we need to identify. So by using the rule, sometimes it is not at all possible to have a final conclusion. See here, a lemur, it is a warm blood type, give birth, but no, it can't fly, it won't live in water, right? But when applying the rule 3, it satisfies at a mammal. Similarly, for the next element, that is turtle, here it satisfies both R4 and R5. So it may be come under reptile and mammal. Then dogfish, shark triggers none of the rule. So like that, some distinct things will come. Okay, because the shark will give birth, but it's live in water, blood type is cold. So we won't match. So in that case, we need to redefine the rule or some mutual exclusive rules we can call or exclusive rules. Like that, we can have some refinement. So mutually exclusive rules in the sense no two rules are triggered by the same record. This usually in operating system we have the property, right? What is the properties of operating system? Four properties, no preemption, hold and wait, mutual exclusion, etc. We studied, right? So same thing. So here, no two rules are triggered by the same record. This ensures that every record is covered by at most one rule. So these conditions we have to impose to avoid the conflict. Similarly, exclusive rules, in the sense there exists a rule for each combination of attribute values. This ensures that every record is covered by at least one rule. Together, these properties ensure that every record is covered by exactly one rule. So, when we impose these mutually exclusive rules as well as exclusive rules, definitely we can able to have a proper rule-based classifier. That's what they are trying to say. Non-mutually exclusive rules may trigger because a particular record may trigger more than one rule. So, what we can do is to avoid that situation scenario, we can go for ordered rule set. Similarly, non-exclusive rules, suppose the record may not trigger any rule, means we can use the default class. So if none of them is applicable, then we will have some other category. So that can be taken as a default class. So these are the things we need to impose further in order to get a success rule-based classification. So now here again, rules are ranked order according to their priority based on their quality, and ordered rule set is known as decision list. Okay, so which one is having the highest priority, that we have to give it in the top list. Okay, so bird, fishes, mammals, reptiles, amphibians. So these classifications already we are having these 5 rules. Now the reptiles. So we have blood type cold, give birth no, can fly no, live in water sometimes. So how exactly we classify? So here we have to create a classification rule in order to avoid the more than one rule triggering. So start from an empty rule, grow a rule using some lag one rule function, remove training records covered by the rule, and we have to repeat the steps until we are stopping the whatever necessary criteria met, we can stop that. Okay, so this is the way we have to cover. So the approach is called a covering approach because at this stage, at each stage, a rule is identified that covers some of the instances. Okay. Now, possible rules set for how exactly we can create. So we have to classify from the diagram C. We have the collection of A and B. So when we draw a line, automatically we can able to so the rules we can, but actually the rules are created with refinement so that it satisfies the scenario so that it will give a clear classification. Okay, so that is what depicted in the next uh, diagram. So a simple covering algorithm, it generates a rule by adding tests that maximize rule accuracy, similar to situation and decision trees. Problem of selecting an attribute to split on, that is a very important thing. Which attribute we are going to split so that we can able to get the maximum rule satisfaction. So decision tree inducer maximize overall purity. Each new test growing the rule and reducing the rules coverage. Okay, so these are the points you need to remember. So definitely the ultimate aim when we are doing the rule based classification is we have to maximize the accuracy, that is the error free solution we are expecting. So total number of instances covered by rule, positive examples of the class covered by rule, number of errors made by rule, that is t minus p. So using this, we can able to get the maximize the ratio. So once we maximize the ratio, mean in turn we are maximizing the accuracy. Okay, so thank you.